Hi everyone, welcome back. Let's write some more Leetcode today. Today we are solving find elements in a contaminated binary tree. So I think the description of this problem is not in the best order. So I guess I will explain it in a different order after having read the description. So first we should know that initially the binary tree will be contaminated. And what that means is just that all the values in the tree node have been changed to -1. So if we look at the constructor, it initialized the object with a contaminated binary tree. And we want to be able to recover it. And to recover it just means that the value at the root node would be 0. And after the root node, every node on the left, if it is not null, then we would do this operation on the left node. And if the right node is not null, then we will do this operation on the right node. So that's what it means to recover the contaminated binary tree. And in the find method, we want to return true if the target value exists in the recovered binary tree. So if any of the target is one of these values that we calculate, then we return true, else we return false. So let's look at this example right here. We want to recover this tree to this tree. So the root node is 0. Left, 2 times 0 plus 1 is 1. 2 times 0 plus 2 is 2. 2 times 1 plus 1 is 3. 2 times 1 plus 2 is 4. So this is a tree that we recover to. And now we check if these values are in the tree. So 1 and 3 are in the tree, so return true. 5 is not in the recovered tree, so return false. So now that we have seen some examples, let's get to how we can solve this problem. So one way that we can solve this problem is that we will use DFS. And as we search through this tree, after calculating the values, we want to add them to a target set. So when we come to the find calls, we can just check if these elements are in the set. And if it is, then we return true. If not, return false. So let's go over this example. So first at the root, we need to set to 0. And now we search towards the left. 2 times 0 plus 1 is 1. So we add 1 to the set. Now we come down to the left again. 2 times 1 is 2 plus 1 is 3. And we add 3 to the set. Now 3 doesn't have a right or left node, so we trace back to 1. 1 has a right node that we haven't calculated, so we do it. 2 times 1 is 2 plus 2 is 4. So 4. And 4 doesn't have a right or left node, so we look at 1. 1 has both right and left node calculated, so trace back to 0. 0 has a right node that we need to calculate, so 2 times 0 is 0 plus 2 is 2. Let's put 2 over here and add 2 to the set. And now 2 doesn't have right or left nodes, so we are done recovering the tree. So now we come to these calls. So 1 and 3 are in the set, so return true. 5 is not in the set, so we return false. And the time complexity will be O of n, where n is the number of nodes, because in the constructor where we have to search and recover this tree, it can take up to n time. And the space complexity will also be O of n because of this target set that we made, that it can take up to n space. So now let's get to the coding part. So in the constructor, we will set the target set to set, self.targets equals set, and we will write our DFS search. So self.dfs root and 0, and we'll write our DFS helper function below. So define DFS self, and we will have a node and a value. So if the node is none, so when we search to the left or right, if they don't exist, then we just return. And if they do exist, then we will add that value to the set. So self.targets.add value. And here we are doing our recursive DFS search. So self.dfs search to the left. And then we perform the operation for the recovery. And we do the same thing on the right node, except value times 2 plus 2, because that's what we are told to do. And finally, in our find function, we just return target if self is in target, and otherwise we return false. All right, let's see if it works. Okay, perfect. Thank you all for watching. I hope this was helpful. If you have any other questions or comments, feel free to leave it down in the comment section, and I hope to see you all again soon.